Hi guys, today's lesson is on the perimeter of polygons. Last week we learned about the difference between regular polygons and irregular polygons. So these are examples of regular polygons down here. To calculate the perimeter of these shapes, all we need to know is the length of one of their sides, and then you can multiply it by the number of sides it has to calculate the total perimeter. The other way they can ask a question about perimeter of regular shapes is they can give you the total perimeter and ask you for the length of one of its sides. So in this shape over here, if we had the total perimeter, we would divide it by 6 to calculate the length of one of its 6 sides because they are all the same length. The other kind of polygons we get are irregular, which means they have different length sides. So to calculate the perimeter of an irregular polygon, all we need to do is add up the lengths of each of its sides to calculate that. Perimeter and area in grade 7, we work with 3 main shapes. The one is a triangle, the one is a square, and the other one is a rectangle. Any other funny shapes that we're given can be made up of these 3 shapes, and so to know the formula for the perimeter of these shapes and the formula for the area of these shapes is what we're going to focus on this week. So if you have a square and it is a regular shape, we are able to say that the perimeter of a square is 4 times S or 4 times L, whatever you call the sides, either S or L. And then a rectangle, because it has 2 pairs of opposite sides that match, we can say the perimeter is 2 L's plus 2 B's, 2 lengths plus 2 breadths, or we can simplify it by saying it's 2 of L plus B. Then to determine the perimeter of any triangle, add the lengths of the 3 sides and make sure that you are working with the same unit of measurement. So these units of measurement are going to be our next thing we look at in this section, and they become a very important part of perimeter and area. Okay, so now we move on to this really important concept of converting metric units. We can't calculate a perimeter if the units are all given in different measures like centimeters, meters, kilometers. We have to make them all into the same unit so that we can add them or subtract them, whatever the question requires. So if we are moving from a smaller unit, from millimeters into centimeters, if you're going into a bigger unit, you must divide the value that you're working with. So, for example, if we had 50 millimeters, we would divide it by 10 to get 5 centimeters. If we had 400 centimeters, that would only be 4 meters. So how do we get from 400 to 4? You need to divide by 100 to get 400 centimeters to be 4 meters. So what's the quick way to remember this? When you're going into bigger units, you must divide. But what you divide by is, well, you're not really dividing the value. The value stays the same. So 5, whether it becomes 50 or 500, that 5 stays in place. All that we're actually doing is moving our decimal place to the left or to the right. When we divide, it means move your decimal place to the left. Let's look at our example we've got over here. So we've got 5 centimeters. We want to move it into meters. So we say 5 centimeters, divide by 100. So we're doing this conversion over here. From centimeters into meters, you divide it by 100. So if you look at the 100, it's got 2 zeros. That tells you you're moving it 2 decimal places over, and we move the decimal comma to the left to divide. So if you look at this little picture here, the decimal for 5 would normally come after the 5. And now if we're going to divide it by 100, we go 1 loop, 2 loops, that's divide by 100. And you can't just leave those spaces there, you must fill them up with zeros. So here we have 0,05 meters. So that's how we would divide to get from centimeters to meters. You divide by 100. Now if you're going from larger units into smaller units, then you're going to end up timesing, because if we had Let's say 6 kilometers. 6 kilometers would be much more meters. So we would have 6,000 meters. How did we get from 6 to 6,000? You times it by 1,000. So look at our example down here. If we're going from 2 kilometers, now we know to get to meters we must times it by 1,000, which means that we must move the decimal by 3 places. So how do I get to 3? I count the number of zeros. Look, 1, 2, and 3 decimal places. And now we're moving them to the right because we are multiplying them. Okay, so let's look at today's exercise. Please do this work in your workbooks or on a piece of exam paper. Take a photo and then either email it to your teacher or upload it to your Google Classroom. There is a form for you to fill in there. So the first thing it says is convert these measurements to meters. Can we remember how to do that? On the previous page, it showed us that to get from millimeters to centimeters, we divide by 10. To get from centimeters to meters, we divide by 100. So that makes sense. To get from millimeters into meters, we're going to divide by 1,000. So have a look here. If our decimal comma was normally at the end of this number, so I'm looking at this question over here, it's 637. After the 7 would normally be your decimal place over there. So if I'm dividing by 1,000, I'm moving it by 1, 2, 3 places. So here I go, 1, 2, 3 places, and I reinsert the decimal over there. So it gives me 0,637 meters. Please put the unit on. Over here, I'm going now from kilometers to meters. So now instead of dividing by, I'm going to multiply by. There are 1,000 meters in a kilometer. So I must multiply by 1,000. And to multiply by 1,000, we move, this is divide, you move your decimal to the left. To multiply, we move our decimal to the right. So again by 1, 2, 3 places. So I move this decimal place 1, 2, 3 over, and I reinsert it at the end. Now all these zeros on this side can fall away, and I just get 56 meters. So please try that using the table on the previous page. If you need to, you can pause it on that table, or if you've written yours out already by now, that will help you. So try that to convert question 1 and 2. Name these polygons. You should be pros at that by this stage. I'm going to leave that to you. Calculate the perimeters of the polygons in centimeters. So if you have a look here, these are all in centimeters, but oops, those are in millimeters. So you're first going to have to convert those into centimeters, and the same for this diagram over here. That's in meters. Watch out, you're going to have to convert that first. Okay, so let's look at question 6. It says copy and complete this table. For the first question, we look at a square with sides of 40 millimeters. In a square, we know that all 4 sides are the same length, so we can multiply the 40 millimeters by 4 to get a perimeter of 1,600. You may use your calculator for this section. In a rectangle, we know that it's got 2 lengths and 2 widths that are the same, and so we can say 2 of these lengths plus 2 of these widths will give us 160 as the perimeter. In this rectangle, they've given us the perimeter and then the length, and they've asked us to find the width. So we know that this perimeter is made up of 2 lengths and 2 widths. So if we took the 2 of these lengths off this perimeter, so 120 minus 2 of 40 leaves us with 40, and that amount is 2 widths. So we need to divide that still by 2 and get an answer of 20 as the width. In question D, we're given a square with the perimeter of 400 millimeters. So that's quite easy. We say 400 divided by 4 gives us 100. Oh dear, but look here. The answer is in centimeters. So it gives us 100 millimeters. To get 100 millimeters into centimeters, we must still divide by 10. Let's take that off there. Write our answer over here. We must divide by 10, so we're going to get 10 centimeters as our answer. So remember, if your units are not in the same measure, please remember to convert them at the end. And then over here we have a square again with the side of 2.3 meters. If we take each side, and so we multiply those by 4 because there are 4 sides, and we get 9,4, but this 9,4 is in meters again. So to get from 9,4 meters to centimeters, we're going to say 9,4 meters. Now we want to multiply that by 100. So we're going to move this decimal 2 places to the right, and our answer is going to be 940 centimeters. Try the rest of this exercise on your own, complete the table, and watch out for your units as you go. When you're finished tomorrow, you can mark your work according to the memo. Now question 7 over here, let's read. It says, Kirsten and Anton run laps around the school playground. The playground is rectangular and measures 131.5 meters long and 55.7 meters wide. Calculate how many laps it will take to run a total of 1 kilometer. So if we've given the length and the breadth of the field, we can calculate its perimeter by adding 2 of those to 2 of those. So over here we say perimeter is equal to 2 lengths plus 2 breadths, which give us a total of 374.4 meters. Then they want to know how many laps do you need to complete to get to to get to 1 kilometer. So we first convert the 1 kilometer into 1,000 meters, and then you can keep adding this amount until you get to 1,000, or the easier way to do it is on your calculator, say 1,000 divided by the perimeter gives us 2.67 laps. And normally when you're running a lap, you don't stop halfway through your lap, so we're just going to complete the lap and say it's going to take 3 laps to get to 1,000 meters or 1 kilometer. Please try the rest of these questions on your own, 8, 9, 10, 11, and send your answers through to your teacher.